If you watch our previous video, you will remember this circuit where we used nodal analysis to find the voltage across 10 ohms resistor. And these were the two equations that nodal analysis gave us. Now, I will change the perception over this circuit, as I told you, that I will change the voltage references over the circuit. For example, let's say this point is now not 0 volts, and this point will be 0 volts. That means I ground this node, but I choose to actually think about it as a ground node. And what will happen in the circuit is that automatically you can see if this is 0 volts and if there is a V voltage drop across this 10 ohms resistor, that will push the voltage down on this node until minus V. So there will still be a V voltage drop across the resistor. So therefore, my bottom line will be entirely minus V, and my uppermost node will be entirely 0 volts. But I will let all the currents be in the same directions and try to write the first equation of my node voltage. The first current will be the voltage at this node minus the voltage at that node will be 0 volts minus V divided by the resistance is 10 ohms will still be equal to the sum of these two currents, where the voltage at this node is no longer 20 volts. Remember that normally when it was V at this point, the voltage drop over this 5 ohms resistor was V minus 20 volts. So it should be still V minus 20 volts. Therefore, I will write this node as normally 0 volts minus V minus 20 volts, and here 20 minus V, therefore it will be V minus 20 volts minus V. It is very simple. Don't let this confuse you. Just subtract V from all of the nodes. That means this should be minus V plus VA. So all nodes go down by V. Actually, I shifted the entire circuit down by V. That's all. Therefore, this current would be 0 volts minus 20 volts plus V divided by 5 ohms. And I just ran out of space here. Let me write down here for the last current would be minus V plus VA minus 0 volts minus V plus VA minus 0 volts divided by 5 ohms. So here 0 is cancelled out. So it will be left as minus V is V over 10 ohms will be equal to V minus 20 volts divided by 5 ohms plus, and this thing here is actually VA minus V over 5 ohms. And as you can see, which is the same as my first equation. Therefore, I know that if I use this node, this will be 20 minus V minus V is plus, cancelled. It will cancel, V is cancelled. Minus VA will give me 20 minus VA over 15 ohms. So this is 2 amperes still. Plus, here minus VA plus VA minus 0 volts. That will give me VA minus V over 5 ohms. The same equation. Then I will get the same voltage. So this is always valid. The only thing changes here is actually the referencing. Nothing changes. The voltage drops across the resistors, across the voltage source is always same. The only thing changes is the voltage references. So don't let voltage references confuse you. In a circuit, it is always the minus side is actually assumed to be ground, and the positive side is actually the highest voltage that the voltage source can have.